Hello everyone. So today I'm going to discuss about logistic regression. So what is logistic regression? Logistic regression is a supervised machine learning algorithm used for classification problem. So basically supervised machine learning algorithm means that the input and output both are defined and the model get trained from the label data. Unlike linear regression, so first of we have studied linear regression, then comes the logistic regression. So unlike linear regression, which predicts continuous value, it predicts the probability that an input belongs to a specific class. So logistic regression predicts whether the input belongs to a specific class. So it is used for binary classification. It comes under binary classification, in which the output can be yes, no, true, false, or 0, 1. It uses sigmoid function that converts inputs into probability value, that is 0 or 1. What is a sigmoid function? The sigmoid function is a mathematical function used in logistic regression to convert any real value number uh, into a value between 0 and 1. So it is basically a function that we used in logistic regression to convert a value into a value which comes under 0 and 1. This makes it ideal for binary classification problems. As logistic regression works under binary classification, sigmoid function helps logistic regression to work under classification problems. Okay, so where the output represents the probability. So here's the mathematical formula for sigmoid function. Um, Here z is equals to 1 by 1 plus e to the power minus z. Here z is equals to w into x plus b weighted sum of inputs, and e is Euler's number. Here is the graph of logistic regression. It is basically a curved graph. Then comes a S-shaped curve. Then key features of the graph is x-axis represent the input feature. Here the x-axis represent the input features, and the y-axis represents the predicted probability. The y represents the predicted probability from 0 and 1. So here are some basic libraries used in logistic regression. First is NumPy. NumPy, as we know, it is used for mathematical calculations or numerical computations. Then we use pandas. Pandas are used for data loading and data manipulation. Matplotlib is basically used for data visualization. And then we use sklearn. Sklearn is used to plot graphs or for implementing some functions. For example, main library for implementing logistic regressions. It also provides tools for model training, evaluation, data splitting. So here is as here we can see, we import NumPy as NP, we import Matplotlib as PLT. From sklearn, we call linear model, and from linear model we import logistic regression, which is the model. From sklearn we call dataset, and from dataset we import this dataset, load breast cancer. For logistic regression we use this dataset. As we have seen in linear regression, we use iris for load iris. So for logistic regression we use load breast cancer. Then we import pandas as PD. From sklearn we call model selection and import train test split. And then again from sklearn we call matrices and import confusion matrix and accuracy score. So here is the pipeline for logistic regression. First we define the problem, then we collect the data. Here the data is load breast cancer. It is a dataset which we gather from Kaggle. Then we perform data processing. Under data processing comes data handling missing values, encoding categorical features, feature scaling, removing noise and outliers. Then we split the dataset into two parts: train and test splits. Training set, it is basically divided into 70 30. Here is the code for train and test. Then comes the model training, that train the model by minimizing log loss using optimization techniques like gradient descent. Then we train the model under train the logistic regression model. Then comes the model evaluation. For evaluation of model, We evaluate the model under few categories like accuracy, precision, recall, F1 score, and all this come under confusion matrix. Then prediction is being performed. Use the trained model to predict class labels for new data. So this is the code for prediction. So thank you. This is all for logistic regression.